Kirchhoff's law. Kirchhoff formulated two laws, and the first law is known as junction law, which states that the sum of all the currents entering in the circuit is equal to the sum of all the electric current coming out of the circuit. The first law is also known as conservation of electric current. Now, let us consider an electric current I is entering in the circuit and the current I1, I2 and I3 is leaving the circuit. In order to explain this, what I'm going to do, I'm going to use this information to draw a figure. So here is my figure where you can see I ampere of current is entering the circuit and I1, I2 and I3 ampere of currents leaving the circuit. So basically we can say that sum of all these currents I1, I2 and I3 should be equal to the current I. So we can write I is equal to I1 plus I2 plus I3. The reason why, because whatever current enters the circuit, only that amount of current can leave the circuit. So in this case, sum of all the outgoing current, which is basically I1 plus I2 plus I3, is equal to the incoming current I. Now let's talk about the Kirchhoff's second law, which is known as loop rule, which states that in any closed junction, the algebraic sum of the change in potential is zero. In order to explain this, what I'm going to do, I'm going to consider a closed loop or a closed junction, which is right here, where you can see that I have four endpoints A, B, C and D, and we have connected resistance across each arm of this rectangle. Then the potential difference between point A and point B will be VB minus VA. Potential difference across point B and C will be VC minus VB, and potential difference between C and D is VD minus VC, and in the same way potential difference between D and A is VA minus VD. Now, the law states that sum of all the potential differences. So let's add all these potential differences. So we will write sum is equal to VA minus VD, which is from here, VV minus VA is from here, VC minus VV is from here, and VD minus VC is from here. So what we are doing, we are just following the law which says that add all these potential differences, and if we add, we will get zero, which simply means that sum of all the potential difference across a closed loop is zero, and that's why the sum of all the potential differences across the loop A, B, C, D, A is 0. Now let's talk about the sign convention for the electric circuit. So the first circuit that I'm going to consider is this circuit, where this is the negative end and this is the positive end. So if I want to find the potential difference between end A and B, I will write VB minus VA is equal to positive V. Now if I switch the polarity, then the positive end is now A and negative end is V, and if I want to find the potential difference between A and B, I will write VV minus VA is equal to negative V. Now let's consider a circuit where end A and V are given like this, and the current is flowing from B to A and a resistance R is connected, and if that is the condition, we will write VV minus VA is equal to positive IR. Now the next circuit is this circuit where I have switched the polarity. Now the current is passing from A to V, and if this is the condition, then VV minus VA is equal to negative IR. These sign conventions are very useful when we solve a mathematical problem, and this is how we will define the Kirchhoff's law.